let's see, let me bring the chat. Yeah, me too. Thank you. I like my hat. Yeah, my son and I are huge fans of SpaceX. He's graduating this year from as an aerospace engineer at Purdue. Okay, so you can see me there. And all right, so today we're going to do the midterm review. And also we're going to go through the PDF that I shared earlier. I think it was late last week, that included a whole bunch of questions that are representative of what you might expect in the upcoming exam. Let's see, there's a question here. Can I use promo code store procedure to get 20% my first order of SpaceX merch? Sure. Yeah, so oh yeah, so that reminds me, the material that's going to go out for the exam this coming Friday is going to be everything up to and including store procedures, but not triggers. Okay, so functions, store procedures, right? Anything that views, things like that. And although I didn't have questions for sample questions for that, but you can use the ones that from the quizzes as well as for reviewing that. So yeah, so everything up until store procedures, functions, no triggers. Okay. So anyway, I did share with you a PDF, so we're going to go over that. Also, I was going to ask folks if they would prefer to do the exam either Friday to Sunday, right? So Friday morning all the way to Sunday at midnight, or if you would prefer to instead do it from Saturday to Monday at midnight. Either one is fine, whatever you prefer. I'm going to do a poll on Piazza and see what folks would prefer, and then we'll go with that. Okay.
In like either case, will we have class on Friday?
Yes, we'll have class on Friday. So Friday is a regular lecture day. We're gonna continue covering the same material that we started late last week. We started talking about programming from outside of the database, right? And we talk about Java and how is it that we can connect to the database and retrieve data. So we're gonna do more of that. Makes no sense to review the midterm because we're like in the middle of folks taking the midterm. You don't have to take the midterm during lecture. We're gonna have just a very regular lecture day. And what else? I think that's it.
Wait, how long is it gonna be?
So I think it's gonna be like 3 hours. Okay. Open book, like you've seen in the quizzes. Obviously, you're meant to work on this on your own, and have some questions that they're going to be equally difficult for everybody, but it'll be random. Hopefully, no two students are going to have exactly the same set of questions. And again, that's to discourage folks from collaborating with one another. But I mean, there's no way that I can stop that, right? That's up to you. You cut out in the middle of the answer for me. Just a heads up. Uh-oh. What question was it?
It was just the one that you were answering. You just became a little robotic for a second and then it went silent, but then it caught back up. But just to let you know, it might happen throughout class.
Approximately how many questions? So it'd be like 30, 40 questions. Yeah. All right, so let's take a look at the PDF that I shared with the class, and I'm going to be using my iPad so I can draw and complete the. We can work on it together, and so you can see what I draw here. Will the questions be multiple choice? Yes, there's going to be lots of multiple choice. Lots of fill in the blanks. fill in the blanks are very similar to what you've seen in the quizzes, and the multiple choice are going to be very similar to the PDF that I shared with everyone late last week, and we're going to go over that today. Okay. All right. Let me share my screen here. I think I need to turn that on here. Will we get our grade when we submit? Yes. And again, we're going to make every effort to make sure that there are no ambiguities in the questions, that they're not, two different answers for the same question. But if you do find any errors, any mistakes, if you could please, afterwards, after everybody's done with taking the exam, either Monday morning or Tuesday morning, I'll make the exam available with all the answers. Then, take a snapshot of the particular question you had problems with, and just shoot me a private message on Piazza, and then we can take a look at it. We'll regrade it. We'll give points back to everyone, right? If indeed it was a mistake of ours, right? So certainly. We definitely we've been making an effort to make sure that whatever grade you get is representative to the effort that you put into it. Okay, let's see. Let me try and share my screen here. Let's see, screen share, start broadcasting. Okay. So can everybody see my iPad screen?
Yeah.
We're good? All right, excellent. Okay, so let's go over this. Maybe let me see if I put this. Okay. All right, so let's go over each one of these questions. So the first one says, consider the following schema, right? Consider the following schema order, right? And it has the table order, right? And it has fields customer, order date, and order price, right? And so the first few questions here are lots of using aggregation and group by and whatnot, right? Just to make sure that you understand what's the correct syntax, right? That the use of aggregations, where can you use these aggregation functions only in the select statement. You can't put them in the where clause. You can't put them in the from clause, only in the select statement. And also in the select statement, you can only put fields that you have group by, that are in the group by clause, or that are aggregated versions of those fields, right? But you cannot put any other things in the select clause. So these set of questions are measuring, making sure that you understand those concepts, right? So here's one that says, select the statement that best implements the following query. So the query is, you want the sum of all orders, right, per customer. So per customer kind of gives you a hint that you are grouping by the customer, right? So there will be some, group by, right, something customer, and the customer is here, customer, and so there'll be something like group by customer here, right, customer. Okay. Also, it says that the sum of all orders, right? So that's presumably there's going to be some kind of aggregation, maybe sum, right? And then we're going to be summing orders here. So what do we have orders here? We have orders. And presumably it is the summation of all the prices, right, of the order, like the shopping cart, right, of how many items you might have, and each unit price, right, added all together, right? So presumably the order price, so order price over here, right? So if we look at these examples, sample question answers, right? Most of my answers in my quizzes, usually you'll have two questions that are two answers that are obviously wrong, right? Very, very quickly to tell that they're wrong. But then there's usually two answers that are very, very similar to each other, and you just have to see where do they differ and why is one better than the other. Okay, so let's take a look at this, right? So we know that we need to group by the customer. So we have a group by customer here. So that's potentially correct, right? Maybe this one's grouped by customer. This one's grouped by order price. That makes no sense, right? We don't want to group by price. We want it by the order. Okay, so that's definitely out of the bat. I'm not even going to read the rest of the answer. I'm not going to waste time there, right? This one's also grouped by order date. So I'm not even going to. Okay, so the only two that are left are between these two. Okay, so we need to see what's the difference between these two. Notice that they both have the aggregation sum order price. So no difference there. They both have from order, no difference there. They both are adding to the select clause this customer and customer. Is that correct? Can we put even in there the customer field? I know we can put aggregations of all the other fields, but what about customer? So customer, notice that it is the field by which we are grouping, right? So that's okay, right? We can put here fields by which we're grouping. The only difference between these two select statements is that we have this order date here, right? Which I don't have in the first one, okay? And we said earlier, right, that we can only put in the select clause, we can only put fields that we have grouped by, right, or that we have aggregated. So definitely this is no good, right? So I'm gonna throw out this one and I'm just gonna keep the one before, the first one. That makes sense? Okay, any questions there? Also notice that I have a syntax error here. I missed a comma here, right? And usually, you know, small things like that, you know, we're not going to try and fool you into, you know, say, oh, you know, you didn't catch the fact that we missed a comma there, and that's why it was wrong. Right? So things like that, you know, we're not going to be trying to catch you on petty things like that, right? We might move things around and whatnot that that are more obviously wrong, right? But not you know, small things like that. And if you do, please let us know. And if it was confusing, let us know, and you know we'll give you points back. All right, so let's look at the second one. The second one says, consider the following schema. We have a student and we have a major, right? And they both have their own primary keys, right? And it looks like the student has a foreign key here that references the primary key over here, okay? Now, in most of my quizzes now, I make these fields much more obvious, right? So I'll probably, you know, next to the primary key, I'll probably put a PK right next to it so that you know, it's unambiguously a primary key. So this would also be a primary key like that. It's not really part of the name of the field. It's just saying that this is a primary key, okay? So in your answers, you should not, you know, you shouldn't have to type actually PK, right? None of that. Right? So it's just to let you know I'm documenting this as a primary key, and probably this will be documented as a foreign key, right? And as a nomenclature, right, the name of the foreign key will have the same name as the primary key that it's referring to, okay? All right, so anyway, so having said that, given these student and major, it says, what are the min and max graduation year per major? So per major, that kind of gives it away that we want to group by the major, right? The major, right? It appears here in major ID in the major table, but it also appears in the major ID here. Yes?
You just cut out again.
I cut out? Okay, thank you.
Yeah.
Yeah, let me back up a little bit. And yeah, here we have per major. And that kind of gives it away that we need to group by the ID of the major, right, of the major table. But there are two of them here, right? We have one here in the table of major ID, and we have also as a foreign key in the students. Okay, so we to see let's see if we could quickly identify which one of these answers are grouping by these fields. Okay, so let's see. Well, this one is grouping by major ID, so that's promising. This one's grouping by graduation year. Well, that's not right, right? We don't want to group by graduation year, so that's definitely wrong. So I'm not even going to bother reading the rest of the answer. This one's also grouping by graduation year. Again, I'm not even going to consider that. There's plenty of stuff that's wrong here, right? Notice that we're using aggregations on the where clause, and that's also a no-no, right? So that's definitely a no. We're not going to waste time there. Okay. Here is also grouping by major ID. So that one's promising. So it's definitely between these two, right? Between these two answers. So which one? Let's see. Well, let's see what's the same or different between the two. And so they're both doing aggregations min and max, which is basically what they're asking us to do, right? The min and the max of graduation year. So they're both promising there. Actually, everybody does that, right? They're all doing that. They're all doing that, right? So that's good. So they all have that. So it's still between those two. What else are we doing here? What are we doing? So this one, notice that it is displaying the notice that this is displaying the major ID, right? Which is what we've grouped by. So is that valid? Yes, it's valid, right? If we're grouping by a field, we can definitely put it in the where clause. Yes. What about over here, right? So over here, in this last one, we're also grouping by major ID and we're displaying it, and that's valid. We can do that, right? But notice that we're also displaying the major name, right? Okay, that's not valid, right? We can only include in the select clause things that we have grouped by, right? So this kind of gives it away that this is not correct, right? So we're going to not consider that, and we're just going to keep this first one. Okay.
Professor?
Yes.
So, like, quick question on that, like, so we still can't display the major name even though it would correlate with the major ID?
Well, there's no guarantee that the major name is unique, right? And so we're not grouping by it, and so
Okay.
it could be that it's different, right? So so the only thing you could do is maybe aggregate them, although aggregating a string would look funny, right? So only numeric values, perhaps. So yeah, so it's a syntactical error to include something that is not in the group file.
Yeah, so we should just like never assume that those will correlate.
Yep.
Gotcha.
All right, so here we have now two other tables, the order and the product. Again, we have primary keys on both, and looks like the order has a primary key, a foreign key that refers to the product. Okay, and it's asking us, how many orders per product, right? So again, so probably this is a group by some product, right? And this how many, probably it needs to be some kind of count, right? And we're counting what orders, right? So what do we have orders here? Now orders, how would we count orders? Would we count the order dates, the foreign key, the PID, or would we count the primary key? So usually it's a when you're counting, usually it's a good practice, right, to count things that are not going to be null, right? So there's no guarantee that order date is not going to be null, right? Perhaps PIDs, you could make sure you could guarantee that perhaps those are not null, but definitely primary keys are not going to be null, right? So it's a good practice to when you do a count, always count guaranteed not null things, right? So we would count something like in the order ID, the primary key of orders. Okay. We go here and start looking at whether we are grouping by the product, by the products, right? And again, we can group by the product ID, P product.pid or order.pid, right? So let's look at where do we do that. So this one is grouped by order product ID. So that looks promising. What about this one? This is also grouping by product order ID. What about this one? This is also grouping by product order ID. So it looks like they all group. Oh, well, not this one. This one's grouping by order date. So definitely not this one. Okay. So let's look at the other ones, right? Let's see. It looks like this one is counting the order ID. So that makes sense, right? We said that that's what we're counting. That's what they want, right? How many orders. That's what we're counting the order IDs. This one is counting the product IDs. That's not what we want. We don't want to count the products. We want to count the orders. So definitely not this one, right? So it's definitely between these two. Okay. So they both count the order ID. They both count they're both ordered by the product ID. Okay, and they both are from the order. That's correct, right? The only difference is that here, right? Let's look at the select statement. We are displaying the product ID by which we are grouping, right? In both cases, but here we're displaying the order date. And again, order date is not in the group by, right? So we cannot include anything there that is either an aggregation or that it has to be in the group by, right? Since this is not, right, this is not correct, and so I'm going to keep the first one. Okay. All right, so let's take a next one, right? So in this one, notice they're getting a little more challenging, right? In the considering only just one table, then two tables. Now this one's going to be a three table, and so let's take a look at. So this one gives us three tables. Right, and three tables that have, notice that the student and the section, those are primary keys, right? But there's no relationship between the two, right? There's no way to navigate between the student and the section. The only way to get from one to the other is through an enrollment, which has foreign keys, right? Two foreign keys, one referencing the section and one referencing the student, okay? So this is kind of like a mapping table, right? So this is kind of like a mapping table. Maps between the two, right? So mapping maps students to sections, right? So it's a mapping table. So the question is the following query legal? Okay. All right. So let's see. Let's see if we can find something wrong with this, right? Let's see. So it has an inner query. This inner query over here. Okay, that is going to be part of some from clause. That's fine, right? That's just in an inline view. We're giving it a name, the inline view, which is then being referenced here. That's okay. And looks like this field, right? Is that field inside of Q? Well, yeah, it looks like it, right? We have SCID is part of Q, so that's correct. So that looks okay. How about inside here? We are grouping by SCID, and that's part of the of the select clause. That's okay, right? We're counting the enrollments IDs. That's also okay, and we're doing a rename. That's also okay. Now out here in the where clause, right? We are taking this num as here, right? And we are referencing the Q, so that's okay too. And we're saying equal to max Q dot number of A's, right? And this is where the problem is, right? We are using an aggregation where we're using an aggregation in a where clause, and that's a no-no, right? You cannot have aggregations in the where clause, right? You can have aggregations only here in the select statements, right? Never in the where clause. And the reason is that, right, if you remember the way that the group by works is that you group by after you have identified what are the records that you're going to group, right? And so the where clause has to happen first and identify all the records that are going to be grouped by, and then you can group them, right? Here, that identification of the records hasn't happened yet, right? Only after you identify the records, then you can do the grouping and the aggregation, right? So that's why this is not valid. You cannot have aggregation functions. If this would be a having clause, then yes, you could do that, right? It's not even a group by, right? It's it's not using any aggregation, right? So anyway, so it's not legal, so it's false. So here's this question is about data access objects. That's a topic that we just started on last Friday. We haven't covered it completely, so that's going to be in a later quiz, right? And again, you'll see it again in the final exam, right? But not for this exam, right? So data access objects is not, so DAOs, right? We talked about DAOs last.
Professor?
Yes.
Sorry to interrupt. When you were finishing the explanation for the last part, you cut out a bit. I think the only thing we need to know, though, is that it's false because aggregations cannot be in the where clause, only in the select statement. But I don't know if you said anything else important.
No, I had mentioned that that the reason that we cannot have aggregation in the where clause is that we have not yet identified what the records are that need to be aggregated. Right, that first you run the where clause, you identify the records, and then you can do all your aggregations and groupings and whatnot. Yep.
Thank you.
The order in which it happens. Yeah, so no DAOs, no DAOs. This is also DAOs, so no DAOs in this in the midterm. This is again DAOs, no DAOs. Okay, so let's take a look at this this question. We're giving a functional dependencies. We haven't covered functional dependencies. We covered it very, very lightly, but not enough to be able to answer this question. Yeah, so no functional dependencies. We did cover functional dependencies when we talked about normalization, and we had said that all the fields, all the non-key fields, right, need to be dependent on the key fields, right? That they should not depend on each other, for instance, right? That whenever you have a field, a non-key field dependent on another non-key field, you're breaking third normal form or second normal form or blah, 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 right? So in that sense, we did cover a little bit of functional dependencies, but not enough to be able to answer these questions. So this is an upcoming topic that we're going to cover next week, right? And you'll see it in an additional quiz a little later, but we haven't yet covered this. So yeah, no functional dependencies. This is functional dependencies. No. Functional dependencies. Okay, UML diagram. All right. So I also shared with you a class diagram, or a couple of class diagrams that I emailed you earlier. That talks about several databases, right? One I think is the school database. The other one is the financial database, and stock database, and the other one's like the airlines database. And many of these questions are going to be referencing a UML diagram that I'm going to be sharing with you. It's not going to be these diagrams. I'm going to share some other diagrams for this midterm, and then we're going to ask you questions about that UML diagram, right? So this is asking, taking a look at the UML class diagram for the school database, right? Answer the following question, right? So let's take a look at the school database. And so let's see the school database. Where are you? There it is. Right. So there's the school database. And the school database is as follows, right? We have a department, right? And the department has a one-to-many relationship with the course, right? So the course has a foreign key that references the department. The course has a one-to-many relationship with a section. So one course has many sections. And then we have an enrollments table, right? That is a mapping table that says what students are enrolled in which section. Right, I did send out a message that there was a typo in this database, right? And that this one-to-many is fine, right? There's a one-to-many between the section and the enrollment, that's fine, right? But this one-to-many is flipped, okay? This should be many to one, not one-to-many. Okay, this should be many on the enrollment side and one on the student side, okay? It's basically just a many-to-many mapping table, okay? And then you have the student, you have zip code and whatnot. That's it. Okay, so let's go back here. So the question is, given that UML diagram that says, which of the following statements which of these statements best implements the following query? Right? It says which students get the highest grade in a course titled CS3200 in the semester of spring 2015. Right? List the student's ID, first name, last name, and final grade. Okay. All right. So let's take a look at it. Right. So we need to say which student. So somehow the student need to find a student, or plural, which students, right? Got some grade that is equal to the highest grade. Right, so we need to be able to calculate what the highest grade is in a specific course in a specific semester. Right, so we need to identify first those courses for that semester in that particular course and then we need to aggregate, right, finding some max, right, of the grades in that group, and then that value, presumably a single value, right, and we need to then compare it against some student's grade, right, and see, and then we can compare that and say, okay, well, it's these students, okay. So let's look at these queries, right? Let's look at this query. So notice that all the queries have the following, they all begin the same, right? We are selecting here, right? The select this from the student table, right? The student ID, the first, the last, and the grade, right? From the student whose grade is equal to something that is on the left-hand side, yes? And they all start the same way. They all start the same way, okay? And notice that this equal here is comparing, right? It's comparing one value on the left-hand side equal to something on the right-hand side, right? So it's comparing, basically, it's expecting that on the right-hand side, you have a single value, right? So what is the highest grade? This is the highest grade, right? And then I want to say, well, what students got that highest grade, okay? I'm going to identify them. So they all have the same beginning, right? What is the student that has that highest grade? Okay. All right. So now let's focus on the query on the right-hand side, and let's see what we've got. Okay. So this one's saying, okay, notice that it's maxing the E grade, right? So it's looking at the enrollment grade. Now they're all doing the same, right? Max E grade, max E grade. So they're all doing that. They're all aggregating all the grades and returning which one is the highest grade. Yes? Okay. So they're all doing that. They are all joining all these three, right? The enrollment, the section, and the course. Remember there's right in the in here, right? We have the enrollment. Right, we have the course, the section, and the enrollment, right, and the student. So we can definitely join all those three. So those are all joinable, right? So we're joining those three: enrollment, section, and course. Notice that they're all doing the same, right? Enrollment, section, and course. Oh, okay, this is different, right? This one is only joining enrollment and section, and this one is doing enrollment and course, right? This is doing enrollment and course. Does that make sense? Let's see. The grade is in the enrollment, right? The grade is in the enrollment. Let's see, the grade is in the enrollment there. Okay. See, there's the grade. There's the grade for the enrollment, and we have references to the enrollment and the section. Right, because notice that we have a one-to-many between the section and the enrollment. That means the enrollment has a foreign key to the section, but there's and then the section has a foreign key to the course. Yes, right. We need the course because we need the title. Right, we need the title because we want to compare it against the title of the course. Correct. And we need the enrollment because we need to filter by the semester. Right. So we need to be able to join all these three tables, right? Because there's no connection between the course and the enrollment, only through the section. So all these three need to be joined, right? So these two that are only joining the and the course, there's no way to connect between the two, only through the section. So there's something suspect about this query. Okay, notice that it's trying to fool us into thinking that we can join using the table itself, right? That doesn't work, right? This section table needs to be in the from clause, and it's not. Okay, so definitely this is no good, right? What about this one? This is doing the same thing, only doing the enrollment in the section and doing the course table, right, as part of the where clause. That's also incorrect, right? The course would have to be part of the from clause. You can't just use the name of the table in the where clause without, referencing in the from clause. So that's also no good. So we're only left with these other two, right? So let's look at the difference between these two. So they're all joining the correct three tables, Let's see if the joins are correct. Let's see. We're going from the enrollment section to the section. That's correct. And from the section to the course. That's correct too, right? We can navigate from the enrollment to the section and from the section to the course. That makes sense. How about over here? Same thing, right? Same thing. So that's correct. So that's good. That's good. Yeah. What about the filtering here? We're filtering the title, both the course. That's correct. And the semester on the enrollment. That's correct as well, right? So I guess the only difference is that you have a group by over here and you don't have a group by over there. You see that, right? So what does that mean? Well, that means that this aggregation here, this aggregation over here is occurring for what? It is occurring the aggregation of all the records. So this is looking at all the records, right? Whatever the where clause comes back with, right? Notice that it's not grouping it. That means that it takes this as if it were one big group, right? And so it aggregates across all the records in that group. Yes, right? And it calculates, through the grade, grabs all the grades, and it comes up with a single value. And it's a single value that is going to be compared against the grade of a specific student or students. Yes. So that looks right. What about this over here? Oh, I'm sorry. We do have a group by. I'm sorry. We do have a group by. Yes, we do have a group by, meaning we're going to have several groups. We're going to have several groups, and we're going to have a maximum for this group, a maximum for another group, and a maximum for another group. So this comes up with what? Comes up with multiple maximums, one per group, that cannot be compared against the single grade of the student. Whereas here, right here, we don't have a group by. We don't have a group by, right? We don't have a group by. That means that we are aggregating across all the records in that one single group, right? And we are coming up with a one single aggregated value across all the records identified, right? And we're grouping it as one single value which we can compare against the grade, right? So this one is no good because we are trying to compare multiple maximums against a single grade in the student, right? And whereas this one has a single value that we can compare, so we're going to keep this one. Okay.
Can you explain that last part again? Just your reasoning of why you eliminated it?
Because this one has a group by. There's a group by, so it doesn't. So this max, right, doesn't come back with a single value that I can compare with a student grade, right? Instead, it comes back with multiple maximums, one per each group, right? That I cannot compare a scalar, against a set, right? So I can't. They're not comparable, right? Maybe if this would be in, maybe, right? If this would be in, then I can do a scalar in a set. Whereas this returns a single value on the right-hand side and a single value on the left-hand side, and now they're comparable, right? So a scalar against a scalar. Okay.
Thank you.
All right. Awesome. Welcome. All right. So let's take a look at this one. That says. So let's take a look at the airline database. In the airline database, it's going to ask us some grouping questions about the airline database. So let's take a look at the airline. So the airline database is this one over here. We have the airline here that we have a flight. So one airline can have many flights. So there's the one-to-many relationship between the two, right? And then the flight, right, can also have a one-to-many relationship with reservations. So one flight can have many reservations. Makes sense, right? And the reservation, then the reservation can have many tickets. So one reservation can have many tickets, right? And let's see, I think there's a question. There's a question on the chat. Oh, looks like I cut out again. Yeah, so let me repeat that, right? The reservation, right? There's one flight can have many reservations, right? And one reservation can have many tickets. Okay. meaning that if we're a family, right, we can all be part of the same reservation, right? And one reservation can have many folks, many tickets, right, that are for the same reservation. And so the ticket information is just it's actually a mapping field, a mapping table, or a mapping class, right? That is saying that it's saying which passengers belong, right, to which reservation, right? It's saying all these folks, all these people, this family of 6, right, are all traveling together. They're all part of the same reservation. Okay, so ticket information creates that mapping, right? This reservation can have lots of those folks. Okay, and then finally, the passenger can have a cuisine, right? A favorite thing that they might want to eat. Okay. All right. So having said that, let's go back to the question. It says which reservations of flights going to New York, right, has a total cost of $400 or more, where the total cost of the reservation is the sum of the prices of all the tickets in that reservation. So we need to, for a given reservation, we need to identify all the tickets. Okay, we need to add them up and then say, oh, okay, so this reservation, if you add up all the tickets, you're gonna come up with the total amount that you need to pay for that reservation, the cost of that particular reservation. So, a family of 3 or 4, right, $100 each ticket, right? It's $400 in total, right? So we need to group by reservation. We need to group by reservation, and we need to add up, right, all the costs of each one of the tickets, right? And so if we go back here, right, we'll notice that here's the reservation, right? But the cost is here, right? Here's the price. The price is in the ticket. So we're gonna need to join the ticket, and we need to join with the reservation, right? Because some information we need to group by the reservation ID, but we need to add up all these prices of all the tickets in that reservation. And also,
Professor,
yes.
I think you cut out for some people again.
Yeah. I need to change my spot and find a better place. Maybe upstairs. I'll try again next time. Sorry about this. Although it is being recorded, right? So you can take a look at it again. Hopefully that might help. Yeah. So right. So we have some information that we want to group by. We want to group by the reservation ID, right? And the cost and the price of each ticket, right, is in the ticket information, right? So these are the prices that we're going to have to add up. Right? We're going to have to add up all these prices of all the tickets that belong to the same reservation, grouped by reservation. But we also want to be able to filter out and identify which flights are going to New York. And that information is in the destination over here, right? This destination, right, is in the flight. So we have some information in the flight, some information in the reservation, some flight in the ticket info. So we need to join all these 3 tables, group by the reservation ID, add up all the ticket prices, and filter by the source equal going to New York, right? So let's go back and let's try to do that. Okay, so we're grouping by the reservation. So we're grouping by this value here. There is reservation, and we're from the flight, right, the destination, and we are calculating the cost from the ticket prices, right, that we are adding up. Okay. All right. So let's look at our choices here. Let's look at our choices. Okay. So we know we're grouping by ID. Right? We know we're grouping ID. So let's see if we can find somebody who's not grouping ID, so we can quickly throw that out. Maybe we can find something. Let's see. So this one is grouping by ID. So that looks promising. Let's leave that one alone. This one is also grouping by reservation. So let's leave that one. So this one's not even grouping, right? It's not even grouping by reservation ID. So I'm probably not even going to consider this, right? And so we're going to just discard this one. This one is not grouping either, right? So let's throw that one away as well. Is there another one? Okay, so it looks like it's between these two. between these two over here. Okay. So in this one over here, let's see what's this here. So let's check to see if the joining works, right? We said that we're going to need to join 3 different tables, you know, the reservation, the flight, and the ticket information. So both of them do that, right? And they bring in the 3 tables that we need. They both do the joining. Let's see, we are joining from the flight to the reservation, and from the reservation to the ticket. So that looks right, right? That looks right. What about over here? Same thing, right? We're going from the flight to the reservation, and from the reservation to the ticket. So no difference there. They're both filtering by the destination, right? In the flight. So that looks right. So the where clause looks the same for both, right? They both look okay. So let's check the difference in the select statement. So in the select statement, what are we doing here? So here we're doing the group. That's the field that we're grouping by, right? So that's okay, right? We have that field. We can, since we put it in the group by, it's legal to put it there. But we're also doing it here, right? So that's okay. What do we have here? So here we're adding the. Why do we want group by in the answer again? Right. So there's a question here. So why do we want the group by? So the question was that you know, which reservation of flight going to New York have a total cost of 400, right? Where, right, the total cost of the reservation is the sum of the prices in that reservation, right? So in that reservation is that if you look at the reservation, it's going to have multiple tickets in that reservation. So we need to group by the reservation and add up the cost for the tickets, right? So that's why we're grouping by the reservation, right? So notice that both of them are using sum to add up the prices of each one of the tickets. So tickets, the prices in the ticket. So same thing, you know, we're aggregating all the prices in the ticket. Okay, so that's good on both of them. Now the difference here is that here we are doing a greater than 400, greater than or equal to 400. What's that all about? And here we're not. Okay, instead the logic of filtering the costs that are greater than or something, here we're doing in the having. Okay, so that's the difference, right? One of them we're trying to kind of like filter in the select statement, and here we're kind of trying to filter in the having clause. That's kind of the difference, right? And well, we know that in the select statement, I can't be filtering in the select statement. It's too late, right? I can only filter in the where clause, maybe even in the having clause, but never in the select statement. In the select statement, I just do projections, right? Unknown caller. Like that. Right, so I can only do aggregations, right? But I can't do any logic of filtering one thing or another, right? So definitely, so this was definitely suspect, right? So that's, I'm not going to go with this one, right? And I'm going to keep just the having the logic that filters out those aggregations. Okay, so I'm going to go with this one. All right. All right, so let's move on to the next one. So this one says lazy loading.
Sorry, Professor, I have a quick question. Isn't sum, when you call sum in the previous question, isn't that also applying some sort of filter and logic inside select statement?
No, sum is aggregations, and aggregations are perfectly fine in the select statements, right?
Okay.
It's not, there's no logic. It's just blindly adding them up.
Okay.
Yeah.
All right. Thank you.
Or average them up, or min and max, right? So any averaging of those functions.
Oh, I'm sorry. You cut out at the end of that explanation. I'm so sorry.
Yeah, no. I'm sorry. Don't be sorry. I'm sorry. Right. So the student was asking if the sum here wasn't that a form of filter, and you know, I was saying that you cannot do logic such as filtering some Boolean expression, you know, on which records are you going to display or not, and so my answer was that this sum or any of the aggregation functions is not really filtering. It's basically summarizing or grouping, not grouping. It's averaging out or identifying the min and the max, or doing some kind of aggregation of multiple values that are a set of values, right? And it's calculating a scalar value from that bigger set into a single value, right? And that's perfectly fine. You know, any aggregation, valid aggregation function is perfectly fine in the select clause, right? Any Boolean expression calculations would be only in the where clause or the having clause. Yeah. Yeah, lazy loading. Lazy loading. That's we haven't looked at lazy loading. That's part of the object relational mapping topic that we're going to get started perhaps this Friday, and we'll talk about that. So that's not going to be on the exam. Lazy loading again. All right, so let's see. So this is consider the following schema. So it's a customers table, and maybe if I stop my video, my own video, maybe I'll have better. Let's see. Is that better? No video.
I mean, I'll keep you updated. If it cuts out, I'll let you know, but
Yes,
it's worth a
please.
shot.
Yeah, I'm trying to lower my bandwidth, see if that's the issue. It might just be Zoom as well. Yeah, because in the previous section I didn't have this this issue before, so weird. All right, so let's take a look at the table of customers, right? And we have fields, you know, primary key, customer's ID, first name, last name, and telephone. And it says if each customer can have multiple telephones, which of the following solutions would not break first normal form? So this is a question about first normal form, right? And if you remember, when we looked at in the lecture about normalization, we had 3 normalizations, right? First, second, and third normal form, and they all dealt with different aspects of redundancy, right? That we want to remove redundancy because redundancy breeds inconsistency, and usually the solution always was to break up some big table into smaller tables, right? Maybe one table into 2 smaller tables, right? And so this is asking us, you know, what's wrong with this table, right? If, right, we want to use it in a certain way. We want to use this table in a certain way. Basically, it looks like customers are not just having one single telephone, we have multiple telephones. How would you, what modifications would you do so that you would still be you know, maintaining first, second, or third normal form, right? So here in particular, which of the following would not break first normal form, right? Okay, so let's look at each one of the options, right? See what's wrong with each one of them, right? And try to identify, you know, which one is good, which one is bad, right? So let's take a look at this first one. So this first one, basically what we've done is that we've broken up the one table. This one table, we've broken it up into 2 tables, right? Customers and telephone, and basically the foreign key that we added to the telephone is referencing the customer. Okay, so this would allow us to have something like this, right? Where we have a customer here and customer 2 here, and then so in the customer table, and then you have in telephones, you could have multiple telephones. You know, telephone 1, telephone 2, telephone 3, you know, all referencing the same customer, right? All referencing the same customer, and then you know 4 or 5 different tables referencing and some other customers, right? So you could have an unlimited number of telephones for each customer, right? As long as you have the foreign key that references that particular customer. So this is definitely a good solution, right? There's no redundancy, right? There's you're not copying this telephone anywhere. It only exists in a single place, so it's good, right? So in this other solution, notice that we've modified the customers table, and instead of telephone, right, singular, we've replaced it with a plural version, telephones, right? It says, should we have CID as our primary key? You mean maybe over here, this one over here? Sure. Although we know that the telephone is unique, and we want to guarantee that the telephone is is indeed unique. So we chose it as the primary key for the telephone, right? We don't want two telephones to be the same, right? They shouldn't have two folks having the same telephone. So we're guaranteeing it to be that way. Whereas this one over here can have this can repeat, right? You can have many telephones using the same CID, right? That they all belong to the same customer. So this could not be the primary key for the telephone, right? Because it needs to be able to repeat, right? So multiple telephones for the same customer. Okay. So this one is taking a look at the solution. It says that, well, what if instead we put if you have multiple telephones, oops, oh no. How do I undo that? I can't undo that. If you have multiple telephones, right? What if instead of having multiple records, we concatenate them into a single string and put it inside of the record, in the course record, right? Inside of one single field, the telephones field. And so the telephones field would be multiple telephones concatenated with commas or some symbol that separates the telephones, right? And we discussed this in the lecture, that this was a bad idea, right? That it makes it much harder to write queries, right? If we're doing a reverse lookup, that we have somebody's telephone and it says, well, which customer does this telephone belong to, right? In this solution, where we break it up into a separate table, that's easy, right? We can just do a query on the telephone, and then from there we can have the foreign key that jumps to the customer. Whereas here, we put them in here, now the query is very complicated because the phone is not represented as a single string, it might be part of some longer string that you need to do substringing and things like that. So it's very, very hard. So definitely not a good solution, right? So this breaks, first of all. And when we say break, breaks, we mean that it doesn't follow or somehow it doesn't meet the criteria for first normal form, right? So breaks first normal form. It's a terminology there saying that it doesn't follow. It says the same schema, but separate records for each telephone. So what this is saying is that instead of having one customer here and then having multiple telephones, right, T2, T3, and referencing like that, instead we would have multiple versions or multiple copies of C1, right, but with telephone 1, telephone 2, telephone 3, right? So the same information, first name, last name, blah, 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 multiple times, but the only thing that changes is the telephone number. And so that is definitely not a good idea, right? Because we are repeating ourselves, right? Multiple times the same information, right? The first name, the last name, multiple times, right? Just because we want a different version of the telephone, right? So that's not a good idea. We're introducing redundancy, right? Since these are non-keys, so there's no way for us to validate that these values are even the same, right? So definitely not a good idea. So no good there. The other option is that we are adding that we might want to add multiple telephones. So one field, a new field for every new telephone there, right? So this would allow you to add maybe up to 3 telephones. But what if I have 4 telephones, right? Or 10 or a whole bunch of them. So this also it doesn't allow me to indefinitely have any number of telephones. Most people will have just 1 or maybe at most maybe 2, and you would end up with lots of nulls and empty spaces and wasted space in a table. And DBAs hate that, right? Waste of space. So definitely not this. So definitely the first one is the better option, and it doesn't break first normal form. And this is the same exact kind of topic that we covered in the lecture in the same kind of explanation. So let's take a look at some other examples of normalization. So this one's going to, you can expect a question on first normal form, another one on second, and another one third normal form. Here's a question about second normal form. This says, consider the following schema that has a composite primary key of course ID and semester. So here's courses, and it has a composite key called course and semester. It also has seats and course name. It also says that there's a functional dependency, right? I know it's using a jargon terminology of functional dependency, in which we haven't formally covered, but we did actually talk about it when we talked about when we talked about normalization. We said that we have to be careful when fields, right, in might be dependent on each other, right? I think we used the example of a person and their birth date, right? And that there was a dependency, right? That one person can only have that birth date, right? And if you know the person you're talking about, then you also know their birth date. So there's a dependency between those two fields, and that would be a bad idea, right? That the dependency should only be on the primary keys, not on each other. So this one is saying that there's a dependency between the course name and the course ID, right? What it says that is that for the course ID, you fully can know what the course name is, right? So for a particular course ID, you can only have that name, right? If you have a different course, then it would be a different name. Yes? So there's definitely a dependency between the two, right? But notice that the course name does not depend on the semester, right? If you have a different semester, well, it would be the same course name, right? Regardless of what semester you're talking about. So there's no dependency between the course name and its semester, right? There's only dependency on a part of the primary key, right? Of the composite key. And we talked about this being breaking a second normal form, right? We said that there's three of them, right? And the mantra is that first normal form says that the fields depend on key, right? And then second normal form says on the whole key, right? Meaning you can have a composite key and it needs to depend on the entire key, and nothing but the key, right? Meaning that they shouldn't depend on each other, right? And non-key depending on non-key. So definitely not, that's a no-no, right? So these are the three ways of remembering each one of these, right? So it should depend on the key, on the whole key, and nothing but the key. And this course name definitely breaks that mantra, right? It's not depending on the whole key. It's only depending on the partial key, right? So which normalization is this violating? Right, it's definitely violating the second normal form, right? Because it's not dependent on the whole key. Okay. All right, so let's keep going. So in this one, we stay with the idea of a composite key, and we're saying that there's a composite key, and here we have non-key fields. We have non-key fields, professor and date of birth. And this is saying that there's a dependency between the two, right? There's a dependency between the two, right? If you fully know who the professor is in this database, you also should know what their birth date is, right? So one depends on the other. You can't have the same professor having two different birth dates. That makes no sense, right? So they're tied to one another, professor and date of birth, right? So one fully determines the other, okay? And so, and that breaks what? That breaks third normal form, right? Third normal form says that, remember, first normal says depends on the key. Second normal form depends on the whole key. And third normal form says and only on the key, right? And this one absolutely breaks that, right? You have these fields depending on each other and not necessarily depending on the key over here, right? So select all the normal forms the schema fulfills. So we know that if it breaks third normal form, right, so fulfill definitely does not fulfill third normal form. Does not fulfill third normal form, right? We don't have a repetition of this data across. So definitely it's okay with first normal form. We have the professor, right? Depending on the whole key, meaning that for a particular combination of course year, you have a professor, and for a different year, for the same course, you might have a different professor, right? So the professor is dependent on the whole key. And since the date of birth is tied to the professor, also the date of birth is also dependent on the whole key, right? So they're both meeting the second normal form, but they're not meeting third normal form because they are depending on each other, right? So it fulfills the first and second, but not the third, okay? Okay, so this one says, consider the following schema with composite key, course ID and semester, and there's a dependency between the course name and the course ID. So the course name depends on the course ID. So this depends on the course ID. So we know already there's something wrong with the second normal form because we didn't say that is depending on the whole key, right? There's something wrong with the second normal form. So this is kind of asking us, which of the following schemas fixes, or which one is a better alternative, right? So basically it's asking us fix this so that it meets second normal form. Right? There's something wrong with the second normal form of this schema. So how could we fix this? So if you remember in the lecture, the way we fixed it was by splitting it into multiple tables, right? And it looks like all our answers are doing that, right? So this one's splitting it, right? So it looks like they're all doing that. And the idea was, right, that we would only leave fields in the original table that only depended, right, on the whole key, right, on both of them. And seats seems to be dependent on both of them, right? So for a combination of a course and a semester, you might have one number of seats, but in a different semester for the same course, you might have a different number of seats, right? So the seats definitely depends on both of them, but the course name only depends on one of them, right? So we want to take this one out. It says, just move it out because this one does not depend on the whole key. Put it in a different table. That's exactly what we did, right? Notice that what we did is we created up here a brand new table that has the course name, that has a single dependency on the course ID. That's perfect, right? It depends on that key, on the whole key, and nothing but the key. So perfect. And in this original table, we renamed it. We called it course seats. Okay, and the seats does depend on the whole key, nothing but the key and the key, whatnot. Yes. What about this one over here? So this one, we have the course name dependent on the course ID. That's perfect. What about this semester? We basically this semester, it was a part of the primary key in the original table, but we kind of moved it away, right? We took it out and we brought it into the courses. So that was kind of drastic, right? We lost the relationship that the seats depends on both of them, right? Depends on the course ID and the semester, but now it lives in a separate table, right? So that's not right. We should have kept the semester in the same table where the seats would have depended on both of them, right? So that's not good. And this one, again, same thing, right? The semester lost the dependency on the combination of the course and the semester, and instead we moved it away into a separate table, right? So let's just keep this first one, which already fixes second normal form, right? Keeping it to the smallest number of table that meets the normalization. Okay. This one says consider the following schema that has a composite key, employee name, and skill, right? And we have a dependency that the name has a dependency with the location and function dependent of employee, and then location and date of birth, right? So we know here that looks like there's a dependency of the employee. So this employee might be Alice, Bob, Charlie, right? And that person also might have a particular skill. But that employee might be working at a particular location, that presumably it's one employee can only work at a single location, right? So it cannot, it would make no sense that, the same employee would be working at a different location. That makes no sense, in two different locations. So these are tied together, right? Unless employees are omnipresent or multi-present, that could be at the same time in two different locations, then we know that there's a dependency between the two, and we clearly state that, right? We also know that for that employee, we have a date of birth, right? There's also a dependency there. So this is kind of breaking second normal form, right? That we have things that are dependent on the part of the key, but not all of them, right? So again, the solution usually is to break this up, right, into multiple tables. What we'll do is that we'll break it up so that all the information about an employee lives in one single place, right? So that we don't have to repeat ourselves that Alice, right, might be indifferent in that specific location. So the way we do that is that we're gonna introduce an employee table that has that captures the location only once for that particular employee, right, and the date of birth, right. So that employee only has one location, only has one date of birth, right. But we're going to use it as a foreign key, primary key, where we keep track of all the skills for that particular employee, right. Plus any other fields that we might have added here, but we don't have any. Here we're splitting it up into a date of birth. That makes no sense that we have a date of birth elsewhere and the employee name somewhere else, right? And location also, this makes no sense. So we're going to keep this first one. So let's look at the this table here that we have passengers, reservations, and ticket, right? Notice that passenger, they all have their own primary key. And but notice that between passenger and reservation, there's no foreign key primary key relationship between the two. The only way that we would navigate between passengers and reservations is by using these foreign keys, right, that refer to both the reservation and the passenger. So ticket is kind of like an in-between map between the two, right? So you have a person, you have a ticket, right? And sorry, you have ticket and you have a reservation. Right, so this ticket is a map between these two, like that, right? So the question is that we want all the names of the senior passengers booked by Alex, okay? So the booking, who does the booking? That's in the reservation, right? That's in the reservation. The senior passenger, that's an age, so that's in the passenger, right? And the name is also in the passenger. So we need to grab some information from the passenger table and some information from the reservation table. So some data from here and some data from here, right? So we need to join, the passenger and the reservation. But the only way to do that is through the ticket, right? So basically, we need to join all three tables, okay? And we need to filter the ones who has the booking agent in the reservation, right? Who's Alex, and also a senior. Senior, we're going to say seniors are folks who have an age greater than or equal to 65, right? So let's see if we can quickly filter out some of the answers. We know that we need to join all three tables. Let's see. So here we're joining all three tables. That looks okay. This one is also joining all three tables. This was joining only two tables, so that looks suspect, right? And here we're trying to trick you that we can join by adding the name of the table as part of the where clause, and that's wrong, right? So that's no good, right? So same thing here, right? We're only joining two tables. Again, we're trying to see if you understand that we need to join all three tables, right? So that's no good. So it's between these two. Right? So let's look at these two. And so let's see. So in both cases, we are filtering by the age, right? And so that tells us that these are seniors. In both cases, we are filtering by the booking agent being Alex, right? So the only thing left to check to see if the joinings are correct, right? So here we're trying to navigate from the person, right, to the ticket person ID. Right, and indeed we can navigate between the person, right, the person and the person ID. So that's okay. So this looks okay, and we also should be able to navigate between the ticket and the reservation, between the ticket, right, and the reservation. So that's okay. I can navigate between those two here. So that looks okay as well. How about this one over here? Notice that this is wrong, right? We're trying to navigate between passenger and ticket ID. That makes no sense, right? notice that there's no relationship between the ticket and the passenger. So that's not good. There's no relationship there. And neither between the reservation and the ticket ID as well, right? So this is not good either. So I'm going to keep just this first one. Okay. All right, so let's look at another one. So here we have three tables, right? Section, student section, and enrollment. Again, very similar to what we had before, right? We have two foreign keys, one pointing to the section and one pointing to the student, right? And we're asking to answer the following questions. We want all the student names. Well, so the student names is where? It's in the student table. In section, in a particular section that has a specific name, right? So section that has specific name. So the name is in the section table. So we need to get some information from the student table and some information from the section table. And the only way to join those two is through the enrollments table that has pointers to both of them, right? And the semester is fall 2018. So the semester is 2018, okay? So we need to join all three. Again, let's see if we can find one that joins all three. Let's see. So this one joins all three. This one joins all three. This one's joining only two of them. Right. So that's probably not good. I'm not even going to look at it. And this joins only two of them. So again, I'm not even going to look at it. Right. And whereas over here, right, we need to see what the filtering is. So both of them are checking the student name. I mean the section name in the semester, right, in the section. So that looks right, both of them. So I guess the only thing to check to see if it's if the navigation, right, between following the foreign key primary key makes sense, right? So in both cases we have the enrollment, right, mapping to the section and mapping to the student. So that looks right, right? It's this enrollment, right, mapping to both of them, the section and the student. And whereas here it looks weird, right? We're trying to join the EID, right? Who cares about the EID, right? Mapping to the section ID, that makes no sense, right? They're not related at all, right? So this one's no good, right? So definitely we're going to keep just the first one. Okay. All right, so let's move on to the next one. So in this one, we're looking at some a table that has similar, right? We want the transaction, right, that is referencing some portfolio and is referencing some stock. It's kind of again a mapping table between the two, right? And we're asking, all the technology stocks owned by John, and where's the ownership? The ownership seems to be in the portfolio table, and the technology stack that seems to be some kind of type of stock, right? And the type of stock lives here in the stock table, right? Again, we need to join these two, and the only way is to go through the transaction. So we need to join all three. So again, let's really quick see if there are any ones that are only joining two. That one joins three. This one joins three, so that's okay. This one's joining two, so I'm not even going to look at it. And this is joining two. I'm not even going to look at it, right? So it's between these two, right? And they both filter on the technology stack equals to technology, and the owner is also John, so that's probably good. So the only thing left to see is to see if the foreign key primary key match, right? That looks right. That looks right. That looks wrong, right? The TID has no relationship with any other primary key, so I'm going to remove that and just keep the first one. Okay. Let's see this one. So this one says quiz. Looking at a couple of classes, quiz and question, right? And if you notice, they both have primary keys, right? But the question has a foreign key that references the quiz, right? In the exam, what I'll do is that I'll add PK and FK so that it's clearly marked that one is a primary key and the other is foreign key. It doesn't say that it's part of the name of the field. It just says that I am documenting it, that these are foreign keys and primary keys, right? And usually what I'll do is that foreign keys will have the same name, right, as the primary key that they refer to, okay? So yeah, so basically this is establishing the following relationship. We have a we have a quiz here, right, that has a one-to-many relationship with a question, some question, right? So there's a one-to-many between the two. Yes. And then it says, but it adds an additional constraint saying that a quiz question cannot exist, or cannot exist without a corresponding quiz, meaning that if the quiz doesn't exist, if I remove the quiz, right, the question cannot remain, right? It should also be removed, right? And we know that we can document that by additionally adding something to this class diagram. I mean, this class diagram is fine, right? It establishes a one-to-many relationship, yes? But we are adding an additional constraint saying that if I remove a quiz, then I need to remove all the questions that are for that quiz. And we know how to document that, right? We can document that with composition, right? So that's composition. Okay. And so that's what we're going to be looking for, right? Composition says that there's a life cycle dependency, that the existence of one depends on the existence of the other, and that goes on the one side, right? Where you have the one, right? Also, diamond all by itself, it's an implicit one-to-many, right? If you only have the diamond, right, it is implied that here's a one and there's a many. Okay, so you'll find sometimes that folks don't put the cardinality, right, and they'll only put the diamond, right, but it's implied. But if you have a one-to-many, it is not implied that it's a composition. Okay, but if you have a composition, it is implied that it's a one-to-many, right? Because if it's a one-to-many, only a one-to-many, then it could be a composition or it could be an aggregation, right? But both composition and aggregation imply that's a one-to-many, but not the other way around. Anyway, so let's look at the options that they gave us. All right, so notice that indeed the first one looks like they are indeed using a composition, whereas here, right, they're using an aggregation, right? And remember, aggregation means that there's no life dependency, meaning that if I remove the quiz, I don't necessarily remove the question. I can keep the question, okay? Right? Whereas composition says that if I remove the quiz, I also have to remove the question, okay? Notice that in both cases, the cardinality one-to-many is implied. And so even though they're not there explicitly, right, they are there implicitly, okay? So this one looks promising. So this definitely is not this one because it's aggregation. So we're not looking for aggregation, we're looking for composition. So this one is also a composition, but notice that it goes the other way around. It's saying that this is a one-to-many going this way, right, from question to quiz, and that's not what the schema is saying, right? So definitely not this one. Now this one is just a what is that? That's inheritance, right? Inheritance, or we call it specialization also, right? Specialization. Right, so this is definitely not what we're looking for. So this is not it. So I'm going to keep this first one. Okay. Now we have this other a relationship between two classes. We have song and playlist, and notice that the playlist has a foreign key that references the primary key of the playlist. So this is establishing a one-to-many relationship between the two. And we have a playlist here. And we have a song, right? And it's a one-to-many between the two, one-to-many. Okay. And so it says here that select the best equivalent UML. Okay. So careful here, right? When it says best equivalent UML, that means that there's going to be some subtle things, right? That I'm going to give you two things that look almost identical to one another, but one is clearly better than the other. Okay. And so this one says, so choose the two diagrams that we're giving you here. Choose the one that one is better than the other. So why would be one better than the other? So looking at it, from like this, conceptually that doesn't seem to be any difference. Right? Notice that the song class, right, and the playlist, right, they both have their fields. Right, and they also have the fields in both representations. So the only difference between the two class diagrams is that the ones below have these fields, right? The primary keys and the foreign key fields, right? Whereas the other one does not. Okay, so the criteria is, well, should these fields be there or not? Okay, and is one better than the other? And what is the purpose, right? So notice that the question says, what is the best equivalent UML diagram? UML diagram, and we had discussed in several times in the lecture, right, that UML really doesn't really care about any specific implementation, whether you end up implementing this as Java or C# or Python or whatever language, whatever object-oriented language you want. It doesn't really care, which implementation. Now, depending on your implementation, whether it's Java or C# or Python or whatever, or relational databases with create statements, right? Depending on your implementation, you might have to tweak, right, or add additional things, right, that mean only makes sense in that specific implementation, right? For instance, these fields, right, only make sense if you're talking about a relational database, right? If this were implemented in Java, it would make no sense to keep these fields around, right? Because there are no foreign keys, there are no primary keys in Java or Python or any other object-oriented programming language, right? So if this is purely UML, you would not add these fields, right? Because you have no idea who's going to be implementing this, right? And UML doesn't care about those things, right? You would only add them, right, if you would want to maybe clarify, right, for a specific audience, right, that you're talking about a specific implementation detail, right? Which here we're not asking for. We're saying what's the best UML implementation. So I would go with the first one, okay, and not the second one, because the second one is RDBMS specific. Okay. All right. All right. So let's look at this second one. So this one says, consider the schema below and the following constraints. The constraint says playlists may have one or more songs. Okay. So this is pretty much the same schema that we looked at earlier, right? We have the playlist, right? And we have the songs. And we know that there's a relationship between the two. And as far as this schema is concerned, just by looking at the schema, only by looking at the schema, we would represent it with the following cardinality. We would have one too many, right? Okay. But, right, if we look at the additional constraint, right, it says may have one or more songs, right? So this one here says it's a shortcut of saying 0 or more, right? That's a shortcut for 0 or more, and this is a shortcut of 1 or 1. Okay. Those are shortcuts saying that the minimum is 0 and the maximum is many. I don't know how many. It could be 0, right? Whereas this one, the minimum is 1 and the maximum is 1. So I know exactly how many I have. It's exactly 1. Whereas here, I don't know, right? So this 1 or more, right? That almost kind of sounds like you want a 1, right? And then more, right? That you have a minimum of 1 and you can have more. But then you have this may in front of this. You have this may have. So may have now kind of says, well, maybe you don't have 1, right? So may have is the same thing as saying as it may not have, right? So the may says that I'm not really sure whether I have a minimum of 1. I'm not really sure, right? So might as well go back to being something vague, like 0 more. Okay, so there's kind of subtle questions on can you parse English, which is inherently inconsistent, is inherently contradictory. Okay, and that oftentimes cause you to implement it one way when we actually intended it in a completely different way. Okay, so we give you several options here, right? We have the one to many between playlists. We have the one to many, right, where you have a minimum of 1 and then a maximum of I don't know how many, right? And then we have some bogus one to many, but then the arrow is wrong, right? And the dotted line doesn't match either. So definitely not this one. So not this one. And this one has kind of like inheritance, even though it has cardinality, it's the wrong arrow, right? This is not this is inheritance, it's specialization, so it doesn't create some association. So let's not go with that one either. So it's basically between these two, right? And again, the only thing that gives us pause here on whether to choose one or the other is your interpretation of may have, right? So may have, again, could be interpreted also as may not have. Right? So might as well just say, well, it could be 0, may have or may not have. So 0 is fine, right? So I'm going to go with the more inclusive of all these possibilities, which is 0 or more. So I'm going to go with this one. Okay. All right. So this one, consider the schema where you have students enrolled in a section taught by a professor who assigns a grade, right? So basically you have students in sections. So basically you have students and you have sections. So students and you have sections. And it says, you know, students are enrolled in sections. So students, so plural students, are enrolled in sections. So it looks like there's a many-to-many between these two, right? There's a many-to-many between these two. But we want to capture the fact that, you know, for every enrollment of one student enrolled in a section, we want to capture the fact that they are being assigned a specific grade and it's being taught by a specific professor. So how do we capture that, right? Well, we could capture it in the originals tables, like the grade for the student and maybe the professor who taught that section, you know, maybe added as additional fields. The problem with that, right? The problem with that is then that would allow that would have a specific grade for specific students, right? And that's the only grade you could possibly have for that student, right? And that's not what we want, right? Same thing for the professor. You know, you can have for the same section, for a different section, you can have a different professor. Okay, so that's not a good idea, right? Of adding grades and professors to as new fields for the students in section. So where would you capture that? Well, probably we need to capture it in a separate class, right, where we can reify this many-to-many. We reify this many-to-many, and maybe do it this way, right? We would have a one-to-many between this, one-to-many like that, one-to-many, okay, and say, well, this is the enrollment table that maps these two. And then we can have a professor and a grade that says, well, for the combination of student and section, we have a specific grade and a professor, right? But now that we have these fields in here, we kind of say, well, wait a minute, we have a you know, definitely this would work, right? This is definitely a verification, one-to-many, right? But normally the way we would capture this, at least in the more modern UML 2.0, we would not use this documentation. Instead, we would keep the many-to-many, right? And instead, we would add this dotted line, right? Because we have these fields, with these added fields. This is an association class, right? That we are capturing new fields about the association. So we use this nomenclature. If we did not have these new fields, then it would be okay to leave this one-to-many on both sides, right? So here are the options, right? Because we have these professor and grade, right? Then we're going to go. Is the reason we're going to go with this solution, as opposed to going with the one-to-many, because we have this professor and grade. If we didn't have these, right? If we didn't have these two fields, then this would have been okay. This would have been totally fine, right? It's just a mapping table between a class between these two, right? Instead of going with this one over here, right? But because we have these two fields, we're going to go with this option over here. Okay. Now this is kind of it's only nitpicking, right? Because even today, it's very common that you find this representation, but it's an older style of representing this, right? The more modern style is to go with this representation when you have additional fields. Okay, definitely not this, because we said that we can't capture the professor and the grade, and definitely not this one because it's got these cardinalities got flipped. You know, they're kind of flipped. What does UML stand for? So make sure that you know your acronyms, right? Definitely UML modern language. It looks like I had it twice, right? So hopefully I won't make that mistake. If you do find something wrong with a quiz, please wait until I make the answers available later on Monday or Tuesday, whenever we decide to have the exam, and then send the instructors a private message, and we'll definitely look to fix it for everybody, right? So that everybody gets any points back for the whole class, right? So we can fix it for one, we can fix it for everybody. Okay. All right. Okay. Make sure that you practice also algebra, relational algebra. Okay, which is basically this these questions that the definitions for: select, project, sort, product, join, semi-join, anti-join. These are definitions. These are drop downs for all the definitions. Make sure you know that. It's open book. You can have them available. Make sure you know how to read these kinds of expressions. Remember that pi is for projection, right? And this is for select. Okay. Make sure, and this is the predicate. That's a predicate. And that also make sure that the outputs of one query can be used as an input for the next query, and sometimes the inner query could return empty. Right? Notice that here we are projecting. We only want the name field, but then we are using a predicate on a field that is not in the project. Right? So this returns is meaningless, right? An empty result. And here's a query. I'm going to solve it for you, and I'll share it with the rest of the class, right? And I'll send it over Piazza. All right, I think I went over my time. All right, excellent. Thank you, everyone.
Thank you, Professor.
All right, remember, if you're watching this on YouTube, to like the video. Bye.
Thank you.
Bye-bye.